ground indication lights in a 480 volts three-phase substation or bus duct are connected in a parallel circuit across the substation's grounding system. Firstly, a neutral or ground busbar is installed in the substation. Secondly, a dedicated conductor, which is a ground conductor, connects the neutral busbar to the ground indication lights. Thirdly, each ground indication light is connected to the ground conductor via a small fuse or resistor. The ground indication lights operate on the principle of overcurrent detection. When a ground fault occurs in the substation, current flows through the neutral busbar and the ground conductor, causing the fuse or resistor in the ground indication light to blow. This breaks the connection between the ground conductor and the ground indication light, causing the light to illuminate. The purpose of the fuse or resistor is to limit the current flow through the ground indication light to a safe level while providing enough current to illuminate the light. In a normal operating condition, with no ground faults present, the ground indication lights remain unlit. The voltage across the ground indication lights is negligible, and there is no significant current flowing through them. When a ground fault occurs, a low resistance path is created between the grounded phase and the substation's grounding system. This causes a significant increase in current flow, which triggers the fuse or resistor in the ground indication light to blow. The blown fuse or resistor disconnects the ground indication light from the ground conductor, allowing the light to illuminate. The illumination of the ground indication light serves as a visual indication to maintenance personnel that a ground fault has occurred, prompting them to locate and correct the fault. Ground indication lights provide a simple yet effective means of detecting ground faults in electrical systems. By visually indicating the presence of a ground fault, they enable quick identification and repair, enhancing safety and minimizing downtime. A ground fault is an unintentional electrical connection between a live conductor and ground. This can occur due to damaged insulation, moisture, or other factors. Ground faults can be dangerous as they can cause electric shock, fire, and equipment damage. Ground indication lights are used to detect ground faults in electrical systems. They are typically connected between a live conductor and ground. When a ground fault occurs, current will flow through the ground indication light, causing it to illuminate. This provides a visual indication that a ground fault has occurred. There are two main types of ground indication lights: firstly, incandescent, and secondly, light-emitting diode, or LED. Incandescent ground indication lights are the traditional type of ground indication light. They are relatively inexpensive, but they are not as energy efficient as LED ground indication lights. LED ground indication lights are more energy efficient than incandescent ground indication lights. They also have a longer lifespan. However, they are typically more expensive than incandescent ground indication lights. Ground indication lights are typically installed in electrical panels, switchgear, and other electrical equipment. They are also sometimes installed in portable electrical equipment. When installing ground indication lights, it is important to follow the manufacturer's instructions. It is also important to ensure that the ground indication lights are properly grounded. Ground indication lights should be tested regularly to ensure that they are working properly. This can be done by using a ground fault tester. If a ground indication light is not working properly, it should be replaced immediately. Ground faults can be caused by a variety of factors, including firstly, damaged insulation, secondly, moisture, thirdly, loose connections, and fourthly, equipment failure. To prevent ground faults, it is important to firstly, inspect electrical equipment regularly for damage, secondly, keep electrical equipment dry, thirdly, tighten all electrical connections, and fourthly, replace any faulty electrical equipment immediately. If a ground fault occurs, it is important to take the following steps. Firstly, turn off the power to the affected circuit. Secondly, identify and repair the cause of the ground fault. And thirdly, test the circuit to ensure that the ground fault has been repaired. Ground indication lights are an important safety device that can help to prevent electric shock, fire, and equipment damage. By providing a visual indication of a ground fault, they enable quick identification and repair, enhancing safety and minimizing downtime. The selection of a ground indication light depends on several factors, including firstly, the voltage of the electrical system, Secondly, the type of electrical equipment. Thirdly, the environment in which the ground indication light will be used. And fourthly, the budget. The voltage of the electrical system is the most important factor to consider when selecting a ground indication light. The ground indication light must be rated for the voltage of the electrical system in which it will be used. The type of electrical equipment is another important factor to consider when selecting a ground indication light. Some electrical equipment, such as motors, requires special ground indication lights that are designed to withstand the high inrush currents that can occur when the motor starts. The environment in which the ground indication light will be used is also an important factor to consider. If the ground indication light will be used in a wet or dusty environment, it is important to select a ground indication light that is rated for that environment. The budget is the final factor to consider when selecting a ground indication light. Ground indication lights range in price from a few dollars to several $100s. It is important to select a ground indication light that meets the needs of the application and the budget. In addition to the factors listed above, it is also important to consider the following factors when selecting a ground indication light. Firstly, the size of the ground indication light. Secondly, the brightness of the ground indication light. Thirdly, the color of the ground indication light. And fourthly, the lifespan of the ground indication light. The size of the ground indication light should be appropriate for the application. The brightness of the ground indication light should be sufficient to be easily seen in the environment in which it will be used. The color of the ground indication light is typically red or yellow. The lifespan of the ground indication light should be as long as possible. Ground indication lights are an important safety device that can help to prevent electric shock, fire, and equipment damage. By taking the time to select the right ground indication light for the application, it is possible to ensure that the electrical system is properly protected. Ground fault protection is a critical aspect of electrical safety in industrial, commercial, and residential settings. Ground indication lights serve as a visual alert for ground faults, but they are often part of a larger ground fault protection system. These systems are designed to quickly detect and interrupt ground faults, minimizing the risk of electrical shock and fire. Several methods are used to achieve ground fault protection, including firstly, ground fault circuit interrupters, or GFCIs, secondly, ground fault relays, and thirdly, high resistance grounding. Ground fault circuit interrupters are commonly used in residential and commercial settings to protect against ground faults in branch circuits. They work by monitoring the current balance between the hot and neutral conductors. If a ground fault occurs, the current balance will be disrupted, and the GFCI will quickly trip, interrupting the circuit. Ground fault relays are typically used in industrial and commercial settings to protect against ground faults in feeders and equipment. They work by monitoring the current flowing to ground. If a ground fault occurs, the ground fault relay will trip, interrupting the circuit. High resistance grounding is a method of grounding electrical systems that limits the amount of current that can flow during a ground fault. This can help to reduce the risk of electrical shock and fire. The National Electrical Code, or NEC, provides detailed requirements for ground fault protection systems. It is important to consult the NEC to ensure that the ground fault protection system is properly designed and installed. Ground fault protection systems should be inspected and tested regularly to ensure that they are working properly. This can be done by using a ground fault tester. If a ground fault protection system is not working properly, it should be repaired or replaced immediately. Ground fault protection is an essential part of electrical safety. By taking the necessary steps to protect against ground faults, it is possible to reduce the risk of electrical shock, fire, and equipment damage. Proper grounding is essential for electrical safety. It provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices, such as circuit breakers and fuses, to quickly trip and interrupt the circuit. This helps to prevent electrical shock, fire, and equipment damage. There are several different types of grounding systems, including firstly, solid grounding, secondly, impedance grounding, and thirdly, ungrounded systems. Solid grounding is the most common type of grounding system. In a solid grounded system, the neutral point of the electrical system is directly connected to ground. This provides a very low impedance path for fault current to flow back to the source. Impedance grounding is a type of grounding system in which the neutral point of the electrical system is connected to ground through an impedance such as a resistor or inductor. This limits the amount of current that can flow during a ground fault, which can help to reduce the risk of electrical shock and fire. Ungrounded systems are systems in which the neutral point of the electrical system is not connected to ground. Ungrounded systems are typically used in applications where it is important to maintain continuous operation, even in the event of a ground fault. However, ungrounded systems can be more difficult to troubleshoot and can be more dangerous than grounded systems. The National Electrical Code provides detailed requirements for grounding electrical systems. It is important to consult the NEC to ensure that the electrical system is properly grounded. Grounding systems should be inspected and tested regularly to ensure that they are working properly. This can be done by using a ground resistance tester. If a grounding system is not working properly, it should be repaired or replaced immediately. Proper grounding is an essential part of electrical safety. By taking the necessary steps to properly ground electrical systems, it is possible to reduce the risk of electrical shock, fire, and equipment damage. The ground indication lights connected to a 480 volts three-phase system typically have a resistor in series to limit current flow during a ground fault. The size of this resistor is selected to provide enough current to illuminate the lamp while also limiting the current to a safe level. The resistor is sized based on the system voltage and the desired current flow. For example, if the system voltage is 480 volts and the desired current flow is 10 milliamps or 0.1 amps, the resistance can be calculated using Ohm's law, which is resistance equals voltage divided by current. In this case, the resistance would be 480 volts divided by 0.1 amps, which equals 48,000 ohms. Therefore, our 48,000 ohms resistor would be used in series with the ground indication light. It's important to note that this is a simplified example, and the actual resistor value may vary depending on the specific application and the type of ground indication light used. The NEC provides guidance on grounding and ground fault protection. Article 250 covers grounding and bonding requirements. Article 230.95 specifically addresses ground fault protection of equipment. These sections provide guidance on the proper selection and installation of ground fault protection devices, including ground indication lights. The purpose of the resistor in series with the ground indication light is to limit the current flow through the light during a ground fault. Without the resistor, the current flow could be very high, which could damage the light and potentially create a fire hazard. The resistor also helps to prevent the ground fault from escalating into a more serious fault. When a ground fault occurs, the current flow through the resistor and the ground indication light will cause the light to illuminate. This provides a visual indication that a ground fault has occurred, allowing maintenance personnel to quickly identify and correct the problem. In summary, the ground indication lights on a 480 volts three-phase system are connected in a parallel circuit across the substation's grounding system. A resistor is placed in series with each light to limit current flow during a ground fault. When a ground fault occurs, the current flow through the resistor and the ground indication light will cause the light to illuminate, providing a visual indication of the fault. Proper grounding and ground fault protection are essential for electrical safety. By following the NEC guidelines and using appropriate ground fault protection devices, it is possible to reduce the risk of electrical shock, fire, and equipment damage.